Hey everyone, and welcome back to the channel. Today, I want to dive into a really interesting concept in the world of AI models, especially when we talk about searching and comparing information, something called multi-vector models. We're used to models giving us a single vector, a list of numbers, to represent something, but what if we used multiple vectors? This diagram shows why that's powerful and introduces a few models that do it. Multi-vector models. And next to it, there's a great visual comparing dense vector versus multi-vector. Let me explain that first, because it's key. Imagine we have the phrase, a very nice cat. With a dense vector, on the left, a traditional model might take that entire phrase and squish it down into one single list of numbers. That single vector tries to capture the overall meaning, which is good for some things. But, in the process, it can lose the specific details about each word or each concept in the phrase. Now, look at the multi-vector example, on the right. Instead of one vector for the whole phrase, this approach generates multiple vectors, maybe one for a very, one for nice, and one for cat. Each vector represents a part of the input. This keeps more of the granular detail. Why is this better? Well, when you want to compare, say, a search query to a document or an image, if you only have one dense vector for each, you just compare those two single vectors. But with multi-vectors, you can compare the individual vectors from your query to the individual vectors in the document/image. This allows for late interaction, meaning the detailed comparison happens after you've created the vectors for each piece, rather than trying to bake all interactions into just one vector up front. The diagram shows late interaction in the top left with maxim and sigma sum, indicating ways these individual vector comparisons are combined to get a final score. Maxim, or maximum similarity, is a common technique where you find the best match between vectors from the query and vectors from the document. Now, let's look at some specific models that use this idea. First, there's ColBERT v2. This is a classic example of a multi-vector model for text. Its architecture shows it takes text as input, turns it into input tokens, processes those through a BERT embedding model, a type of language model, which outputs BERT query embeddings or BERT document embeddings. Notice those aren't single embeddings, they are multiple. It then uses late interaction, like maxim and sum, to compare the query embeddings to the document/image embeddings. Its usage is typically for raw text and handling long-range context, which is where multi-vector is super helpful because it doesn't lose details across long pieces of text. The diagram shows it has around 110 million parameters and an embedding dimension of 128, meaning each of those individual vectors is 128 numbers long. Next, we have ColPali. This looks like a multi-vector model built for images and PDF documents. Its architecture takes image/PDF as input, breaks it into input patches, like small pieces of the image or document page, processes those through a polyGEMMA Vision LM, a vision language model, and outputs GEMMA query embeddings. It also uses late interaction, maxim, to compare. For usage, it's designed for images and PDF documents. The diagram lists around 3 billion parameters, an embedding dimension of 128, and a patch size of 1024. Patch size refers to the dimensions of the small pieces the image/PDF is broken into, in this case, maybe 1024 by 1024 pixels or similar units. Finally, there's ColQuen. This is another multi-vector model designed for images and PDF documents, similar to ColPali, but using a different base model. Finally, there's ColQuen. This is another multi-vector model designed for images and PDF documents, similar to ColPali, but using a different base model. Its architecture takes image/PDF input, breaks it into input patches, processes through a Qwen Vision LM, and outputs Qwen LM embeddings. It also relies on late interaction, maxim. For usage, it's also for images and PDF documents. It's slightly smaller than ColPali, with around 2 billion parameters, the same embedding dimension of 128, and a slightly smaller maximum patch size of 768. What do you think about multi-vector models? Let me know in the comments below.